Hello, so this is going to be a distance tutorial over the molarity and dilution worksheet. I have selected one problem from each of the types on the worksheet, except for one because I could not see the problem clearly in the photo of the worksheet that was sent to me. But otherwise I got one problem from each type. So to start out, we'll do 1A. So the question is, or the problem is to calculate the molarity of the solution. And the solution, and the solution given is 2.00 moles of glucose dissolve in 4.00 liters of total solution volume. Okay, so first we need to address what we're given, what we need, and set up our equation. So what we're given is moles and liters, and what we need is molarity. And molarity is, of course, moles over liters. So to set up our equation, we have what we need. So molarity is moles over liters. We're given moles over liters. So we're going to go ahead and put our 2.00 moles over our 4.00 liters. Get my little line here. Set up our equation like that. We crank out the math on that. So let me do that real quick. So we have 2.00 divided by 4.00 is 0.5. Molarity. Okay, so that is 1A. All right. So the next one that we'll do is 2B. And so this question or problem states, calculate grams of solute needed to prepare the following solution. Okay, and then we are given 125 milliliters of a 0.200 molar potassium chloride solution. Okay, so again, we'll address our given, our needed, and of course, set up our equation. Okay, let me give some more space here. Whoops, way too much space. Okay, a little more space here. So, what are we given? We are given 125 milliliters, and we are given 0.200 molarity. So that is what we have, and it's asking us for grams. So to set up our equation, we are going to travel from potassium chloride molarity to grams of potassium chloride. Okay, so I'm going to write this out. So this setup is going to, we're going to, like I said, start with the molarity. and things will happen in the middle, and eventually we will end up with grams of potassium chloride. Okay, so we have 0.200 molarity potassium chloride, and we know that we need grams. So we know that liters is not going to help us with that, but we know that, of course, moles will help us with grams. So let's go ahead and get rid of our liters now. We'll just get that out of the way. So we have the other volume that we're given is the 125 milliliters. So we need to get rid of the mils. Mils, here's 1 liter. So now we can cross cancel. We're going to get rid of our milliliters, get rid of our liters. So that's done. And lastly, we need to get those moles into grams. So molar mass, right? So there are 74.5513. 5513. Move my little equal sign over a little closer here. Give myself some more space, which I fail to do sometimes. So grams of potassium chloride per 1 mole, right? Molar mass. So we have now cross-canceled that mole, and we're left with grams. So if we crank out the math on that, we end up with 1.868. Apologize for my pen. This touchscreen isn't great, but I hope you can at least see what I'm doing here. So that leaves our answer, 1.86 grams of potassium chloride. Okay, so that was 2B. We will go ahead and do 3C. So 3C, the problem or question is to calculate the volume of the solution. And then it gives us 30.0 grams of lithium hydroxide from a 2.70 molar solution. Okay, so what are we given? What do we need? And what is our equation that we need to set up to get there? Okay, so we are given grams and molarity, and it is asking us for volume, so liters, right? Okay, so we're going to line down here. Okay, so the equation that we're going to use for, so it's asking us about a solution, right? So the equation that I see fit for this problem, for dealing with the solution, I apologize for my yawn, is going to be molarity, and I'll do it like this. So molarity times volume equals moles. Okay, we're going to go ahead and rearrange that. And the rearrangement is going to look like, because it's asking us for volume, right? So we want the equation that we use to be to equal volume. We need to get to volume. So it's going to be volume equals moles, oops, divided by molarity. So let's break that down. So we see volume equals moles over molarity because of our rearrangement. But another way to write that is going to be liters, because the volume is going to be in liters. So liters equals moles over molarity. And what is molarity? Molarity is moles over liters. So when we divide by a fraction, that gets rearranged again. So it's going to be liters equals moles times liters over moles. So you can see how when we set up this equation, we're going to cross cancel our moles and end up with liters. Okay, so with that said, oops, go back up just a little bit. Okay, so with that said, we'll go ahead and set up our problem. So the first thing we'll do, we're given grams. Let's go ahead and convert our grams into moles, shall we? So we will start with 30 grams of lithium hydroxide, and we want to get rid of the grams and get moles. So we're going to use molar mass to do that. So 1 mole of lithium hydroxide over, we're using our periodic table, and we get 23.95 grams when we add those up for a molar mass. Lithium hydroxide, and we can go ahead and cross cancel our grams of lithium hydroxide to give us those moles that we wanted. And we crank it out, and we get 1.252 moles. 1.252 moles of lithium hydroxide. And of course, we're not done because the problem asked us for volume, right? So now we are going to go ahead and plug into the equation for the liters. So liters then, oh, that looked wonky. Okay, liters equals, we're using that equation that we worked above. It's going to equal moles, so 1.252 moles of lithium hydroxide times the molarity we were given, which was 2.70 moles per liter. Oh, I'm sorry. Forgot about our rearrangement. Give me 1 second. Let me get rid of this. Okay, so the equation that we had above was liters equals moles times liters over moles. So that was my mistake. So 1 liter over 2.70 moles of lithium hydroxide. Okay, and so we crank that out, and we end up with 0.4637 liters. And there we go. Oops. Because we were able to cross cancel our moles and get our liters there. So that gives us the liters that that question was asking for. Okay, give us a little more room here, and we will do 4A. Okay, and that question or problem states how many grams of solute are in the solution. So we hear solution again, so we'll be able to use that solution equation again, right? So the information that it gives us is 2.52 liters of 3.00 molar potassium nitrate solution. This 3 is, it's supposed to be a subscript. Let me see if I can Oh, I can. Great. Okay. Subscript 3. Perfect. Okay. Solution. So we tackle what we're given, we tackle what we need, and we set up our equation. Okay, so what are we given? We're given liters and we're given molarity. And what is it asking us for? It's asking us for grams. Okay, so let's go ahead and use the solution equation that we just used above. So that was molarity times volume equals moles. Okay. So if we go ahead and plug in our info, oh, and I'm sorry, I will go ahead and better explain. So we need grams, right? So if we use this equation, molarity times volume equals moles, we have the molarity, we have the volume, that will give us the moles, and we always know that by having the moles, we can get the grams using molar mass. So that's why we're using this equation. Okay, so I'm gonna go ahead and set us up. So we do 3.00 moles per liter, and this is of potassium nitrate. It's 3 potassium nitrate, and we are multiplying by the volume we were given, which is 2.52 liters. And we end up with 7.56 moles. Moles of potassium nitrate. Okay, and so we were able to cross cancel there and get our moles. So now we have our moles, but the equation or the question, of course, asks us for grams. So let's go ahead and let's get, so we'll bring this right down here. So let's go ahead and let's use the moles that we just calculated, and let's get some grams, okay? So 7.56 moles of potassium nitrate, and we're going to use molar mass, so we're going to put the mole on the bottom because we want that cross cancel. We want to end up with grams. 101.1032 grams of potassium nitrate equals, we crank out the math and we get ourselves 764.3402. That is a 4, I apologize, 3402 grams of potassium nitrate. And we can see here, we cross cancel our moles and we get our grams. Okay, so last but not least, let's work another problem. So this one is going to be 5A. And this is a dilution problem. So numbers 3C and 4A, they were solution problems. So this one's going to be a dilution problem, so we're not going to be using the same equation that we used for 3C and 4A. We're going to be using a different equation. So the question or problem says, determine the final volume, of the dilution. Okay, and then it says diluting 50 mils of a 12 molar ammonium chloride solution. Ammonium chloride solution to give a final concentration of 2.00 molar ammonium chloride solution. Okay, so let's see what we're given, see what we need, and set up our equation, okay? So when you read this problem, dilution should be like setting off alarms in your brain for M1, V1, M2, V2. That's great for a dilution equation. And then also, just the fact, and I apologize, I see an error in the way that I typed this, just the fact that you are given 2 molarities and, oh, I see what I did there. I'm sorry. Just the fact that you are given 2 molarities and 1 volume should also kind of be setting off red, little red flags in your head or something that this is an M1, V1, M2, V2 solution because you're given 3 of the 4 numbers that you need for this equation. So you know that you'll be solving for one of them. So we look at the problem. We see that we're given V1. So V1 is going to be the 50 mils. But we also know that when we're working with molarity, we're working with liters. So we're given the 50 mils. We're actually going to write that as 0.05 liters because we need that number in liters because of the molarity. So we're given V1, we're given M1. So M1, see? Okay, so M1 is going to be 12 molar. And when you're determining which one is M1 and which one is M2, it really comes down to the way that the problem is written. So it says diluting the 50 mils of a 12 molar ammonium chloride solution. So you need to dilute that, and it says to give the final concentration. So the final is going with the 2M, and you're diluting the 12M. So that's how you know that your 12M is going to be M1, it's what you're actually diluting, and then what you're going to end up with is the 2M. So that's going to be your M2. So 2.00 molar. Okay, so what do we need? We need V2 then, right? And that's going to be in liters. So the equation that we're going to need is M1 V1 equals M2 V2. So if we set this up, so it's going to look like, oh, you know what? And then actually before I plug in the numbers, let's just go ahead and rearrange the equation because we already know we need to solve for V2. So we do a little algebra, a little rearranging here, and that makes V2 equal to I apologize, V2 becomes equal to M1 V1 over M2. Okay, so now we will go ahead and set this up. So, V2 equals, so what is M1? M1 is 12.0 molar. What is V1? V1 is 0.05 liters. What is, I apologize, what is M2? M2 is 2.00 molar. Okay, so we know that we can cross cancel our molarity and get us our liters. So if we crank out the math, we end up with 0.3 liters. And if that was still in milliliters, you know that you would just, or if the question wanted it in milliliters, if it was like a multiple choice and all you were given was mils or something of the sort, you would just multiply it by 1,000. And that would allow you to cross cancel because there's 1,000 mils in 1 liter. So you could just cross cancel that if needed, if you wanted mils Okay, well that is one worked from each of the problems in the worksheet except number 6 because I could not see it. So I hope that helps. Please let me know if you have any questions about anything that I did. Don't hesitate to contact me. I apologize for the delay, and I hope that the distance tutoring, I hope this method worked. So I'll talk to you soon.